In this video, we're going to take a look at what are statistics. Statistics are facts and figures. So let's take a moment and look at some examples. The largest earthquake measured 9.2 on the Richter scale. Men are at least 10 times more likely than women to commit murder. 1 in every 8 South Africans is HIV positive. By the year 2020, there will be 15 people aged 65 and over for every new baby born. Statistics rely heavily upon the calculations of numbers, but statistics also rely heavily on how the numbers are chosen and how the statistics are interpreted. Sometimes the interpretations are problematic. Let's take a look at a few of these examples and try to identify a major flaw with each interpretation. Here you see a picture of some delicious ice cream. Consider that a new advertisement for Ben & Jerry's ice cream, introduced in late May of last year, resulted in a 30% increase in ice cream sales for the following 3 months. Thus, the advertisement was effective. So our question is, are there any problems with this logic? Yes. A major flaw is that ice cream consumption generally increases in the months of June, July, and August, regardless of advertisements. This effect is called a history effect and leads people to interpret outcomes as the result of one variable when another variable, in this case, one having to do with the passage of time, is actually responsible. In a second example, I'd like for you to consider the relationship between churches and crime. In fact, the more churches in a city, the more crime there is. Thus, churches lead to crime. So our question is, are there any problems with this logic? Yes, there are. A major flaw is that both increased churches and increased crime rates can be explained by larger populations. In bigger cities, there are both more churches and more crime. This problem, which we will discuss in more detail in a later chapter, refers to the third variable problem. Namely, a third variable can cause both situations. However, people erroneously believe that there is a causal relationship between the two primary variables, rather than recognize that a third variable can cause both. As a third example, I would like you to consider the number of interracial marriages that are now occurring in our society. The proportion of interracial marriages this year is 75% higher than it was 25 years ago. Thus, our society accepts interracial marriages. Are there any problems with this logic? Yes. A major flaw is that we don't have the information that we need. What is the rate at which marriages are occurring? Suppose only 1% of marriages 25 years ago were interracial, and so now 1.75% of marriages are interracial. 1.75 is 75% higher than 1. But this latter number is hardly evidence suggesting the acceptability of interracial marriages. In addition, the statistic provided does not rule out the possibility that the number of interracial marriages has seen dramatic fluctuations over the years, and this year is not the highest. Again, there is simply not enough information to understand fully the impact of the statistics. To summarize, statistics are not just facts and figures, they're more than that. Statistics refers to a range of techniques and procedures for analyzing, interpreting, displaying, and making decisions based on data.